So the question that we're working with is determine whether the following equation defines y as a function of x. And we have the equation x squared plus y squared equals 9. So in order to answer this question, we need to know what a function is. A function is a relation such that for each element in the domain, there's exactly one corresponding element in the range. So we definitely have a relation here. X and y are related by this equation. And so we have a relation. So we know we have a relation, but we don't know if this relation has this special property. The special property that for each element in the domain, there's exactly one corresponding element in the range. So that's the part we have to figure out, whether it has that special correspondence. So when we have an equation like this, and we're trying to determine if y is a function of x, we want to rewrite this equation as y equals some equation of x. So we're going to start by taking this equation, x squared plus y squared equals 9, and we're going to solve for y. So we'll subtract x squared, and that gives y squared equals 9 minus x squared. And then we're going to get rid of that square by square rooting both sides. And when you square root a square, that's essentially absolute value of y, or just y. And to get rid of that absolute value, we would get a plus or minus on the other side. So rewriting this equation from x squared plus y squared equals 9 gives us this equation y equals plus or minus square root of 9 minus x squared. And now that it's written in this format, it's much easier to tell whether this property is met. So we want exactly one corresponding element in the range. So if we say choose any x value, and I'm going to choose x equals 0, you're going to see that y is equal to plus and minus square root of 9 minus 0 squared. This is plus and minus square root of 9 plus and minus 3. So what this shows us is that we have an element in the domain that has two corresponding elements in the range, a positive 3 and a negative 3. So the relation that we have here is not a function, because we can see that it doesn't have this special property of having every element in the domain corresponding to exactly one element in the range. So that's just one particular example, but what I have here is just a summary for us to take a look at for questions that are like this. So when you have problems like this, you want to solve for y, write that equation in y equals form, and something that helps you to determine whether it's a function is if you end up with a plus or minus symbol, This is going to indicate that you have two y's, maybe not for every x, but for some x's in the equation. When you have an even power on y, that's what leads to a plus or minus symbol. So you can see in our example that we had a square on the y, and the square is what led to that plus or minus. That's what leads to having two y's for an x value. So that can be an early or quick indicator that you have something that's not a function. So when you have an even power on y. We didn't see this in this example, but another early indicator or shortcut is if you have absolute value around y. That's going to lead to a plus or minus, and that's not a function. In this example, we're given this picture on the right, and we want to determine the intervals on which this function is increasing, decreasing, and constant. So what I like to do when determining intervals of increasing, decreasing, and constant, so I like to look at the big picture, and we start from left to right, and these words increasing, decreasing, and constant are all three of them are describing y. So as we examine this going from left to right, we're going to pay attention to what's happening on the y scale. So starting as far left as we can go, I'm going to trace the graph and notice that the y values are decreasing. And then it's going to change to increasing. And it's going to change to decreasing. And then we have a constant interval. So let's label those. Our first section is decreasing, then increasing, then decreasing, and then we have constant. So I want to write the intervals where the function is increasing, decreasing, and constant. And the intervals are going to be the x. Intervals of x are going to be like our directions. We're giving someone directions on where to look in the graph. We're saying that the graph is increasing on the interval of x. Increasing is what the y is doing. The where is the x. So I can use my ruler here. And the reason why I'm using my ruler, I'm holding it vertically. And this is going to show me where that interval starts, what x value it starts on, and what x value it stops on. So in that x interval, the y values are decreasing, and that goes from -7 to 0. So this function is decreasing from -7 to 0. Now, there is some debate about whether we use parentheses or brackets on these. And it depends on what type of interval you're looking for. Intervals of open intervals or closed intervals. In our class, the book is always asking about open intervals. And when we use open intervals, we're going to use parentheses. So in our book for our class, the intervals will have parentheses on them because they're looking for open intervals. So we go from -7 to 0 for decreasing. So the next interval was increasing. And once again, let me use my ruler. This is going to start at an x of 0 and stop at an x of 5. So over this group of x's, the y values are increasing. So that's from 0 to 5. And once again, because our book looks for open intervals, we'll use parentheses. So the next group of numbers is decreasing. That's going to start at an x of 5 and stop at an x of 8. So over this group of x's, the y's are decreasing. So we're going to go from 5 to 8. And when you enter in my math app, you want to have a comma separating those intervals. This last group is constant. The y's are constant, and it starts here at 8, an x of 8, and continues on forever. So this whole group of x's has the y values being constant. We're constant from 8 to infinity. And so we have our intervals of increasing, decreasing, and constant. The graph is decreasing from -7 to 0 and from 5 to 8. It's increasing from 0 to 5 and constant from 8 to infinity. For this example, we want to find the center, radius, and intercepts of the circle given. And then we want to sketch the graph of the circle. This equation is x squared plus y minus 3 squared equals 9. And in order to find the center and radius, it's helpful to know the standard form of a circle. The standard form of a circle is x minus h squared plus y minus k squared equals r squared. In this standard form, the h and k form the center of the circle, and r is the radius of the circle. Our equation of the circle is written in standard form as well, so we're going to be able to identify that center and the radius. So looking at our equation, we have x squared, and x squared is the same thing as x minus 0 squared. The h, which is the x-coordinate of the center, is the number that's after that minus sign. So we're going to have a center with an x-coordinate of 0. The k is in the other term, the y term, and it follows the minus sign. We have y minus 3 squared, so 3 is the y-coordinate of our center. And then we have on the other side of the equation a 9, and that's where our r squared is. So if r squared is 9, you can take the square root of both sides and get that r is plus or minus 3. The radius is a distance, so we're going to use the positive 3. We have the radius of our circle being 3. So we have a center of 0, 3, and a radius of 3. With that information, we are able to graph the circle. So I'll go ahead and graph it now, and then we'll find the intercepts of the circle. So the center is at 0, 3, which is right here. And then from that center point, we're going to move the amount of the radius in each direction. So 3 to the right, 3 up, 3 to the left, and 3 down. So we're moving from that center point 3 in every direction. And then we can sketch the graph of our circle. Now we're about to find the intercepts, but this is really helpful information. You can see that looks like we're just going to have one x-intercept, and that's going to be at 0, 0. And we're going to have two y-intercepts, and it looks like that y-intercept is at 0, 0 and 0, 6. Now, this is an example where the intercepts are really easy to find graphically, but we're going to find the intercepts algebraically. So when you're looking for an x-intercept, you're going to substitute a 0 in for y. So we're going to have the equation x squared plus 0 minus 3 squared equals 9. That's x squared plus negative 3 squared equals 9. And that gives x squared plus 9 equals 9. I'm going to solve for x. So I'll subtract 9. That gives x squared equals 0. If I square root both sides, I'll get x equals plus or minus 0. And 0 is a neutral number, so it doesn't have a plus or minus. Just 0. So that gives us our x-intercept of 0, 0. Then looking for the y-intercept, we're going to let x equal 0. So substituting a 0 in for x would give us the equation 0 squared plus y minus 3 squared equals 9. 0 squared is 0. And y minus 3 squared plus 0 is just y minus 3 squared. We're going to get rid of that square by square rooting both sides. So that gives a square root and square canceling out. So we'll have y minus 3 on the left. On the right, we get plus or minus. Every time we square root a square, we get that plus or minus symbol. The square root of 9 is 3. We want to get y by itself, so I'll add 3 to both sides. I have y equals 3 plus and minus 3. So we've got our two answers. 3 plus 3 is 6, and 3 minus 3 is 0. So that gives us our two y-intercepts of 0, 6 and 0, 0. Let me zoom out so we can see everything here. We found our intercepts, our center and radius, and graph the equation. Thank you for checking out my videos. Have a great day.